Oh, there we go. I was just fixing to say.
Thank you. If anybody new is here, go ahead and send me your name and your banner ID and send them just to me because it's kind of private. All right. Let's zoom out. So I made a big copy. The notes that I sent you. No. Thanks, Ben. The notes have a
Yep.
smaller copy of the same thing. So what I want to emphasize to begin with is that we've got a circle. The distance between the center, which is 0, 0, and the edge of the circle is 1 unit. And if you think about the general formula for a circle, it's x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared equals the radius squared. Radius is the distance from the center to the edge. Well, in this case, what are the coordinates of the center?
0, 0.
0, 0. So the x coordinate of the center is 0. The y coordinate of the center is 0. And what is the radius?
1.
So the unit circle is x squared plus y squared equals 1. And you would think that such a boring circle would, not have that many uses. It's actually incredibly powerful. So first of all, let's take note of the 4 points that we already know. The places where the circle cuts the 4 parts of the axes. So the positive x-axis is 1, 0. The negative x-axis is -1, 0. The positive y-axis is 0, 1. And the positive negative and the negative y-axis is 0, -1. But do you see, we know 4 points. We absolutely know 4 points, and we know the equation of this circle. Hey, Belladonna, just 1 second. Recording back on. All right. Did y'all finish talking? Did you want to chat? That's always good to chat.
I think we're good.
Okay. So we've got this circle. We know 4 points on the circle. And let's do one more thing. Let's think about a right triangle sitting inside that circle. So what is the hypotenuse of that right triangle?
That green line, right?
Yeah, but
It'd
how?
be 1, right?
Yes, that's right.
Ah,
Okay, so what if we're going to always call this lower angle theta? What if x trying to be creative here? What if x is square root of 3 over 2. What are the possible values, not of b, but of y? If we let y represent the height of this right triangle, we're saying that x, the distance across, is square root of 3 over 2. And now we want to find the possible values of y, the second coordinate, and the height of the right triangle. So is this the same as what we just did?
Yes.
Almost. Yes, almost. So we've got, let's see, let's just look at this. Let's just look at this particular right triangle first. Tell me the formula that I'm going to use to connect these values.
A squared plus B squared equals C squared.
Beautiful. And which one shall we label A, which B, which C?
We can do the square root of 3 over 2a. And y will be b. And then the hypotenuse can be c squared.
Beautiful. So we've got square root of 3 over 2 squared plus b squared. Oh, and we're calling that y equals 1 squared. That's kind of nice. And let's square root of 3 over 2 before we move it. How do you square a fraction again?
You square the numerator and denominator.
Good. So we've got square root of 3 squared over 2 squared. And what is square root of 3 squared?
3.
And what is 2 squared?
4.
Beautiful. So we've got, we want to solve for y. So what should I do?
One minus y squared equals 3/4.
Okay, good. Oh no, I did that thing again. Shoot, I hit the wrong button. You just call it psychedelic math. There we go. Okay, I'm trying to find the focus because it seems out of focus to me. Is it okay to y'all?
Yeah, it looks fine.
Yeah.
Okay, groovy. So we've got y squared is equal to 1 minus 3/4. And
So you got 1/4 equal y squared.
okay, how did we get to 1/4?
Oh yeah, yeah. 4. Well, would you have say? Damn it, I lost the word. But the 1 becomes 4 over 4
Beautiful.
minus 3/4, and 1/4 equals y squared.
Good. And what was I hammering on about before earlier?
When we take the square root, we can't forget the plus or minus.
That's right. So square root of y squared,
Y.
square root of 1. What is the square root of 1?
1.
And the square root of 4.
2. 1/2.
Hey, but this time, does it make sense to blow off the plus or minus? Are we looking at a length or at a position?
A position.
Position. So that means going up will be 1/2,
Positive.
yes, and going down,
Would be -1/2. Okay.
so every single triangle in the unit circle has a friend, a pal, that's almost the same as it. And in fact, there are 4. There's the positive square root of 3/2, positive 1/2, and the radius, the hypotenuse is always positive, always positive, always positive. But the position of X and Y, those can be positive or negative. We can have this triangle. We can have, is this distance now, this position, is it going to be positive or negative? The X,
That'd be negative.
Negative.
okay? And what about Y?
Still positive.
And we have one in the third quadrant.
Negative and negative.
Good. So those 4 triangles are related. Every single one of them has the property that the one leg squared plus the square of the other leg equals the hypotenuse. And let's see that in quadrant 3. I don't know why Roman numerals are always used for quadrants, but they are. So quadrant 1, positive, positive, positive X, positive Y. Quadrant 2, which one becomes negative?
The X.
Y stays positive. Quadrant 3
Both of them are negative.
and quadrant 4.
Positive, negative.
Positive, negative.
Good. So many connections that we're going to have going on here that we need to keep sort of growing. And that's why we started at sort of a basic level so that we can grow from that basic level. Okay. So let's take this interesting one and just see if it really works. Let's take this triangle and let's prove that it really is the fact that a squared plus b squared is c squared, where a is going to be
I'll just let you know we only have 8 minutes left.
oh, thank you so much, Sir Huff. Thank you. Okay, which one shall we call A?
We could do 3 squared over 2.
Good. And B?
Uh,
Negative
negative
1/2.
1/2.
And C?
The hypotenuse one.
It helps, I think, always to let A be the horizontal and always to let B be the vertical, just because it gives you a fixed point. Okay, so we've got, pretend like I'm really stupid and I don't know how they're related. Tell me what formula is.
We'll do a squared, a times a, plus b times b. And then that's all equal to c times c, or c squared.
I'm not quite that stupid, but thank you. And this person I know named Ms. Nell would really love to see parentheses at this step. Not because you need them every time, but because you need them sometimes. Okay, why do we need them this time?
Because you're dealing with square roots,
Not just the
and it
square,
helps to keep track.
say it again, somebody said it.
Because we're squaring the whole fraction, not just the numerator or denominator.
Yes, and there's something else. There's something associated with these numbers that we haven't had previously when we looked at Pythagorean theorem.
Oh, they're negative.
They're negative, right? We've got to have that negative sign inside the square. Why?
That we know that the number's negative, not the output is going to be negative.
Right. Because a negative times a negative is
Positive.
positive. So not only is square root of 3/2 squared positive, but negative square root of 3/2 squared is positive. And the same with 1/2. All right. So let's distribute this square all the way. We've got a negative squared. We've got square root of 3 squared, and we've got 2 squared. And help me do the same thing with the negative 1/2.
So we'll have the negative squared, and then 1 squared, and then 2 squared,
Awesome.
and then just
And
1 squared.
excellent. And negative squared is,
Plus or positive.
Positive, yeah.
so we've got positive and square root of 3 squared,
It's just 3.
2 squared.
4.
Beautiful. This negative squared
Positive.
plus this 1 squared
It's
1.
just 1.
and 2 squared.
4.
And 3/4 plus 1/4 is,
1.
1.
yay. And I didn't pull those numbers out of my hat. Those are numbers we're going to have connecting all the time. Anytime you see a square root of 3/2, you know that 1/2 is going to go with it. And all you have to figure out is plus or minus part. We don't really have time to go from here, but this is a good place to pause anyway, because we've introduced an extension of a right triangle. And that extension has formation with this x squared plus y squared is 1. And you can think of that as coming from any triangle in this circle where the x is the distance from the is the distance along the x-axis from the origin. So that's squared, where y is the height of the triangle, and the hypotenuse is 1 squared. So it's also the Pythagorean theorem. Any questions?
For this week, what's assigned? What do we have to do? And
Um,
by when do we have to do it?
So I want you to finish the prep materials, and there are 4 SLO quizzes for the preps and the exam. And I think the due date for the exam is Monday. The
exam for what? For February, I'm guessing.
February 6th, is that what you mean?
I think so, because you said the exam's on Monday, and looking at a calendar looks
Oh,
like
yes. Yes, this is the 6th on February.
Okay.
And you you're welcome to start the material, the homework 1, 2, 3, and 4. Those are the next ones we're doing. That's over this material. Or you can wait. I mean, we've got time. Make sure that you've got the exam 1 under your belt before you start doing these.
All right, cool.
So
Oh,
finish exam first, then the quizzes.
Say again?
Finish the exam first because that's a practice, and then do the quizzes after the exam. Is that correct?
The quizzes also have multiple tries. Let the first try be a practice. And then the next try be really trying. And what was I gonna say? Oh, and the same with the exam, but do the quizzes and then the exam.
Okay.
And
So
the,
we should do the preps, then the quizzes, then the exam.
yes,
All right.
and the password for exam 1 is there. Creative, yeah. It's the only way I could get Alex to accept that I didn't want to use some other software. All right. Thank you for being flexible. Sorry about this morning.
No, yeah, of course.
You're okay.
Thanks very much. Y'all are wonderful. I'll see you on Wednesday.
Yep. See you on Wednesday.
See you
Yep.
then.
Yeah, Wednesday.
Bye.
All right. Bye bye.